Now, let me help you with your tutorial homework that's due tomorrow. Now, there is no tutorial this week, there is no tutorial next week. It's like a 2-week vacation, but you do have homework due tomorrow. And the last 2 pages of that tutorial is giving some of you grief. And that's because it talks about Galilean transformations. And we never talked about Galilean transformations in this class. But they're not hard. Here's what we mean. Suppose that a red Volkswagen is going to the right at 30 miles an hour, and there's a blue truck, pickup truck, parked on the side of the road. Greg, standing on the sidewalk, sees just that. However, Jeff, riding a yellow dump truck, a yellow Tonka dump truck, at 30 miles an hour to the right, he sees something different. Well, first of all, in his frame of reference, what does it look like that parked truck is doing? Yeah, it's moving to the left 30 miles an hour. What about the red Volkswagen? Well, Jeff looks out the window and there's that red Volkswagen. He looks out the window a little later, there's that red Volkswagen. He's just always seeing that red Volkswagen right out the window. So in his frame of reference, what does it look like the red Volkswagen's doing? Stopped. And so this is what Jeff sees. And that's what we call a Galilean transformation. That wasn't so hard. That wasn't so hard. Now here's the point though. Greg and Jeff do not agree on what the total momentum of the system is. Greg says, oh, I got a red Volkswagen going 30 miles an hour to the right, and there's no momentum here for the truck. Jeff says, oh no, you're wrong. I got a great big blue truck moving 30 meters per second to the left, and the Volkswagen doesn't have any momentum. They don't agree on what the momentum is. They don't even agree what direction it is. I think it's to the right, he thinks it's to the left. However, if the Volkswagen collides with the truck, Jeff and Greg will agree on one thing, that the momentum is conserved. Greg will say after the collision it's still to the right and this big. Jeff will say after the collision it's still to the left and this big. They won't agree what that momentum is, but they will agree that it stays the same. And that's what you're doing on the last 2 pages of that tutorial homework. Now, on the tutorial homework, they don't use 30 miles an hour, they use numbers like 0.6 meters per second. And we got Greg standing on the sidewalk, and that's what Greg sees. Now, in this case, we have Jeff riding the truck to the left at 0.2 meters per second. Now, if those decimal points are getting in your way, just get rid of them. Let's make that 60 miles an hour. Let's make that 20 miles an hour. If you're going down the road 20 miles an hour, and there's a car coming 60 miles an hour towards you, in your frame of reference, where you're stopped, how fast is that red car going? 80 miles an hour. 80 miles an hour. Okay, what about this parked truck? If you're going 20 miles an hour down the road, what does it look like the truck's doing? 20 the other way. Now, if we go back to the decimal places, what Jeff sees is 0.8 for the red and 0.2 for the blue. And that's just a Galilean transformation. Now let me give you a little bit of a warning, a little heads up. Lillian McDermott has a trap in that homework where she tells you that the mass of this glider is 5 times the mass of that glider. What am I going to do with that? Does it matter how big the dump truck is that Jeff's riding? Could it have been a bicycle? Yeah, all that's important is how fast he's going. It doesn't matter what he's on. And so you just have to be strong enough to say, That doesn't matter. Nice try, Lillian. You didn't trick me. Now, clearly, you are getting ready to leave, and I should stop. Okay, let's pick this up on Wednesday.